Hello, welcome to today's webinar covering object storage data lakes for AI workloads with DCIG, Supermicro, and OSNexus. I'm Lauren Grobe, Director of Marketing at OSNexus, and we're glad that you've joined us today. So before we get started, I'll introduce our speakers. From DCIG, we have Jerome Wendt, CEO and Principal Analyst, and he's going to set the stage for our topic of object storage data lakes for AI. Do you want to go ahead one slide, Steve? Thank you. From Supermicro, we have Wendell Wengen, Director of Storage Market Development, who is going to lead our panel discussion. Also from Supermicro, we have Paul McLeod, Product Director, Storage. And then finally, from OSNexus, we have Steve Umbacher, Founder and CEO. So first, we're going to do an object storage overview and trends discussion by Jerome. If at any point you have a question, just submit it into the Q&A box in the bottom of your screen, and we'll get to it after the panel discussion. So with that said, I'll pass it off to Jerome now.
Thank you, Lauren, and welcome everyone. Just want to thank you for joining us today for this look into data lakes using object storage and data lakes to run AI workloads. As Lauren mentioned, my name is Jerome Wendt. I'm the principal analyst here at DCIG, and so sort of set the context for today's conversation and kind of how we got to where we're at. Over the last year, DCIG has spent a lot of time looking at object storage in general, just the different products that are available on the market, and specifically software-defined storage solutions that offer object storage as a feature. And one of the, and when we did our initial set of research, we looked specifically at the use case using object storage as a backup target. But as we began to look more deeply at object storage, I mean, that's always been sort of the historical use case for object storage. Excuse me, performing archive, basically function as an archive or as a and more recently as a backup target. But really, what we saw as we looked at these object storage solutions is that they've really, they've matured a lot. I mean, a great deal over the last 5, 10, 15 years, to the point where organizations are looking at them more holistically as that you can now move them out of this traditional use case of archive or backup as even hosting something as data lakes for AI workloads. But I think, help organizations kind of understand really, or even enterprises understand why it's so viable. I think organizations first they understand is really what we saw across all products and what has really changed in this space. So when we looked at, the different, and we evaluated over 20 different solutions in this space, what we saw across all these different solutions is that if you're looking at these different products, is that they now all offer a cloud management interface. So when you go to manage them, use them, they now offer like web GUIs. They're often have a cloud console where you can log in and manage their products and manage them in a specific way and go down that path. They also now offer cybersecure capabilities. Now, that can mean different things to organizations. That can mean anything from they offer anomaly detection. They offer data immutability. They offer multi-factor authentication. So, features that one maybe not normally associated with object storage, you can now find on these different solutions and be able to manage them that way and actually secure them as well. I would say, of all the features we looked at, performance may have been something that has always been some of the knock on object storage. When I first started covering this object storage years ago, I think, when I even talked to the companies that released the first solutions, they were like, well, don't promise anything under multiple seconds of latency when retrieving any data from the system. Sometimes it was even minutes before you get data out of them. That is no longer the case. Now we're actually talking, really sub-millisecond response times for these solutions. So really that whole context around using object storage just for archive or even backup purposes has really changed. It's now really has production level capabilities of performance. The other thing too that we saw across all our solutions that we evaluated is they offer hybrid cloud capabilities. And I think you have to be kind of careful how you define hybrid cloud. It can mean one of two things. One, it stores data locally, and then it archives data off to another tier of storage, sometimes even like a cloud object storage provider, located somewhere else. Or it can also mean, in the case of SDS object storage, it can mean it can actually run in the cloud. You can actually use virtual servers or virtual machines on the cloud and configure it there. I would say that's true across, both those applications are true across almost all the solutions we looked at, where it could satisfy one or both of those different use cases. And then I think the other reason that organizations are often, maybe drawn to object storage, especially as it applies to like data lakes, running AI workloads, is the fact that you could use lower costs or existing server hardware that they have in place. So they can organizations may deploy it on here, they can run it on these things, so they can essentially get their AI initiatives off the ground more economically. If you can advance the slide now. Now, when we look at specifically, as you look at those that are specifically suitable for enterprise workloads or enterprise spaces, there's some specific features stuck out again. Again, this is true whether you're considering the data lake use case or the backup use case. One of the things that we really found intriguing about these different solutions is that they all offered concurrent file and object access. Now, that is not universally true of, again, across all object storage. Some may offer a file access, but those that we specifically identified as enterprise capabilities have concurrent file and object access. And what that means from a practical perspective is that maybe you're more accustomed to you can configure these for file access and then come back and use the the Amazon S3 SP APIs to come back and retrieve the object that way, or vice versa, using your A3 APIs to store the data, then come back and present them through a file interface. They both support both those different access methods. We also found they also all supported data immutability. And again, for more organizations that, again, we looked at more of this from the backup target use case, where organizations are using it for that one, but it's still applicable here too, as all organizations are now concerned about the production data being compromised by hackers, maybe by internal threats, so you can implement multi-factor authentication, and you can introduce different means of data immutability, whether that's through compliance or governance modes of data immutability. And they support these different modes. The other thing we also found too is high availability. Now, you often hear about object storage in the context of durability, that they have 10, 11 nines of durability, but high availability is also entered into object storage as well, where you can now confidently get 4 nines, 5 nines of data high availability of these solutions. Which again, when you think about not just in the context of backup, which is where we did the analysis, but also you looked at data lakes, running AI workloads, organizations cannot have downtime in these environments because these are often time sensitive. They're trying to build their models for their AI workloads, for their large language models. And as they do that, they need these high levels of availability. Well, these all offer 5 nines of availability now through the architectures that they have put in place. And that also kind of falls into the disruptive upgrades as well. While you're running your AI workloads and you're building your different models, things are going to go wrong. Fans may fail, hard drives may fail, or they may perform intermittently, where you have to actually go in and diagnose the problem. Basically, what these solutions allow you to do is now you can go in here and you can actually make these upgrades, or someone comes out with a new software release, you need to do these, can perform the continual maintenance to assure the stability of your system. These solutions give you that level of availability, the background up needs to continue running your operations uninterrupted. And finally, the solutions scale to tens of petabytes. Now, not every organization, every enterprise out there is necessarily going to need to scale into the tens of petabytes with these specific solutions. But even scaling into the petabytes, that becomes very relevant for, depending on the type of large language model you're running and how large it's going to be. So if we look at, sort of the different, if you go forward to the next slide now, when you look at the 4 phases of LLM production and how, really how well it maps to what organizations are doing, or how they anticipate using object storage in this use case. Again, historically they've maybe used high performance file systems with parallel file systems to do this, but now they can realistically look at using object storage in this particular use case. So we're actually going to spend a lot of time on this in today's presentation, talking about how well it maps to this and how well this particular OSNexus Supermicro solution really maps into this. But just at a high level, like when organizations consider about data ingestion, the amount of data you ingest, certainly if you're going to look at ingesting multiple petabytes of data, object storage really becomes very practical in that for both two reasons. One, it scales to very high levels, but also it can handle these different types of workload. I mean, when you're doing the data ingestion, the write traffic is very heavy because you're pulling in data from all these different sources. You're scaling up, so you have to both scale economically and you have to scale to very high levels. Object storage really facilitates that first stage of what organizations are looking to do. But then as the data ingestion essentially starts tapering off and you start preparing the data for use in your AI workload environment, organizations then start reading a lot of this data. They start manipulating it. They start creating, they basically make smaller vectors of it as they go through this data reduction stage, as they basically cleanse the data and use it to train their models. And so again, object storage is very well suited for this because again, it facilitates these high levels of read and storing large amounts of data so it can scale economically and move into the sort of the model training and model deployment and inferencing, which are the final two stages of the LLM production. Now, as you think now about the sort of the data lake specific attributes, and again, I've already kind of touched on these, but again, they're kind of universal, whether you're looking at object storage in general as a backup target, or in this case for a data lake, you care a lot about the high performance. And really as it begins to, first you have to care about where you store the data and the metadata. If you're going to store it on flash, object storage now supports flash, both to store the metadata, to store the data, or some mix thereof where you have to store some data on flash and some data on disk. So you can get that, sort of you get that right, cost performance balance or ratio for your environment as your environment grows, as you do your AI workloads. It's scalable, and by scalable I mean it can be scalable both incrementally because it can scale both up and out. By so you just need to add small amounts of capacity, small amounts of performance. We're looking. You may need to scale that way. You may also need to scale, significantly. We have to scale, handle multiple petabytes of data. We look at and we look at the solutions we're looking at here today. They are going to, facilitate both those more incremental or more larger upgrades of both performance and capacity. And finally, we look at some very cost-effective ways to do it, where you can manage different types of systems. You can introduce different types of components into your infrastructure that you can then scale out economically. So we look, so as we get ready to kind of bring in OSNexus and Supermicro into the conversation, you're really going to see, and what DCIG really discovered was really how they can effectively scale capacity and performance out and or up, both independently and cost effectively. And you're going to see some of the different models that Supermicro can bring to the table, that organizations can introduce into the cluster, and how OSNexus can discover them and then basically scale them out and allow you to manage that. OSNexus is specifically going to give you some specific ways to do auto tiering with this intelligent data placement, which is really sort of a distinguishing feature of their solution and what it can really deliver for your environment. And then finally, organizations think about manageability. I mean, I came out of a data center environment. I worked one 20 years ago when I worked in a mission critical environment. I mean, it's the way individuals used to describe the environment where I used to work in. They said it was like trying to change tires on a 747 while I was coming in for a landing. Okay, the environment where I worked in, one of the outages we had was we made the 6 o'clock news that night. Okay, on all three major networks. And my boss ended up getting fired because they didn't handle a storage upgrade effectively. Okay. And, okay, I'm not saying everyone's going into these sort of environments that, you're going to be managing OSNexus and Supermicro in that sort of environment, but you really need that sort of level of visibility all the way down to the very core component levels. I mean, sometimes you need to know what hard drive has failed, what fan has failed to avoid those sort of major outages that have those significant impacts. Well, because of the integration that Steve and Paul are going to elaborate on, you can actually see right into the Supermicro solutions, right through the OSNexus console, and really do that sort of deep level diagnosis that one typically doesn't see in what one considers like a more of an open source solution where you bring it together different components. I mean, they have this deep level of integration that you really only might find or expect from a hardware, proprietary hardware solution. So sort of with that setup, I'd like to, now we can, kind of sort of give you an overview of the sort of solution you're getting. I mean, you're not really getting a commodity solution. I mean, yes, these are more economical solutions, but these are definitely not what I consider cheap solutions. Okay, these are really enterprise level solutions that organizations are bringing to that Supermicro and OSNexus are bringing to the table that really give you what you might normally not get from might not expect from this sort of combination. So Lauren, I'm going to turn it back to you so you can introduce the other speakers, and we can really do a deep dive into the solution that Supermicro and OSNexus are bringing.
Yeah, I think we'll pass it off to Wendell to lead the panel discussion. So thank you, Jerome.
Great, and thanks, Jerome, for that very thorough overview of the different uses of object storage. And picking up from what you talked about, we know that object storage has really historically been used for high capacity, mostly unstructured storage, and it's still a very popular use case as you described, Jerome. But now object storage is really becoming a key element in the AI training and inference pipeline process. So for our panelists, I would like you to talk about the role of object storage in the AI data pipeline.
Yeah, I could start there. This diagram here that we put together really goes through top to bottom the whole AI pipeline, the various phases of producing a large language model. And one of the interesting things is that the data parallelism that is used in producing these models really lends itself towards using object storage. Object storage is great for workloads where you're writing files which turn into objects and then you're reading them, but you're not actually modifying the individual objects or the files. And that's exactly what you have here. You got these early stages where you're pulling in huge amounts of data into a large object store so that you can then process that and in later stages feed that into the model. So this first stage is really where the most capacity is required. This is where you're bringing in all the raw data. It has not yet been processed. And then in the next phase of that, you're going to take that data and turn into tokens and producing the embeddings. And there's a huge amount of cleaning and deduplication that happens in that phase. And so your 100 petabyte will reduce down to maybe 1 petabyte or 100 terabytes in that process. So there's this massive reduction. And an object store is just perfectly suited for this early stage. And it's very well suited for the next stage. But since you're getting this massive reduction here, this next object store can be all flash and in a cost-effective way. And with the QuantaStore platform, we can have this tier here be both object and a parallel file system at the same time. So you get double use out of this, both as hosting the process tokens, as well as being that vector database for your customized information that you're putting in to go and augment the inference servers queries and things.
Steve, I was, just kind of curious when I think about all those different Supermicro nodes coming in access and they're running the different API calls into that. Can you talk a little bit just how well it handles those different all those requests and all those multiple nodes all running at the same time? I mean, to me that it's kind of a fascinating. I mean, to me that just seems like a great use case for object storage and really how it lends itself towards that.
Yeah, when you are using a large language model, you're really interacting with these inference servers. And so you're going in through a REST API and you're kind of using the already produced model. So this in the bottom right-hand side, you're seeing like the model has been loaded onto local NVMe storage in the GPU servers. And then that query goes and grinds that request through the various stages of the model to get a result back out. And that is oftentimes augmented with a vector database that can have some additional information that's specific to that organization. It's sort of like if you have made at a prompt a query where you gave it a whole bunch of additional information and said, hey, can you go and include this as part of the information used to go produce my results? The vector databases are doing that for you. And so there needs to be a sort of high performance place to go and query that vector database, which can be this all flash storage tier here. So the inference servers do need some high performance storage, but the model themselves are typically going to be deployed many copies on local storage across all of the nodes, because that's just the most cost effective and highest performance way to go and load and use the model. Whereas these GPU nodes up above are really would be used for training the model, and you can use the same GPU nodes for doing inference and the model training. I'm showing that as two separate sections here, or groups of servers, but those could be used for doing both of those workloads at the same time, because they're both requiring GPU nodes. It just kind of depends on what scale you're at and the environment.
Interesting. Okay.
And yeah, in these stages, these earlier stages where you're cleaning the data, everything really lends itself towards parallelism, because when you've got like a raw, whether it's a video or text or images, those things are going to get chunked up into pieces using, there's some LLM usage to go and produce the vectors using an embedding model, and there's various different embedding models, and those are changing all the time as well, which is why you can't just throw out the raw data. If the embedding model changes, you got to reprocess and produce those new vectors, and you're constantly getting additional data added to your raw data set, because things are changing, right? Your business is evolving. But whether you're processing logs or you're processing certain data sets from the internet, this raw data that you're feeding in is changing, and the embeddings can be changing. And so there's a need for, in a lot of cases, for having a large object store, and then these pieces that are sent through the cleaning process. These can, use more standardized Hadoop clusters in the middle here. So this green arrow, you could think of it as like, using more traditional style, large, server clusters to just go and walk through those data using traditional pipelining techniques like Spark and Hadoop there. But then at the end of that, you've got these tokens that have been produced that you can then start to feed into the model. And the tokens are also chunked up into pieces, and then they're fed into the individual GPU servers to work on, which again is perfect for object storage. And you can see here, each of these stages, you're just writing and then rereading, processing, and then writing and then rereading. It's not like you're taking these tokens after the fact and then editing them in here. You're editing all the models within these nodes, and when you get to various epochs, points in time, you'll go and push those checkpoints back into the object storage. And the checkpoints are super important, because you want to save the model as you go along at different points in time, which are called epochs, because what happens with these large language models is they get better and better and better, and then they overfit to the data and they start getting worse. And you want to be able to go back in time to when those points in times where it hit its most its optimal, most highest accuracy as a model. And so yeah, these checkpoints can take up a lot of space. You're basically saving a full copy of the model every time you take a checkpoint.
Thanks, Steve. I think that was a really good explanation about the entire training and inference process. And Paul, I know you have a similar kind of view of this. Why don't you share that with us?
Yeah. So from a historical perspective, and really the challenge of 2025, we think of AI as being this thing that was sort of a big surprise for the world, right? That happened a couple of years ago. That everyone, this is what this really could be. This is either scary or really exciting. But in terms of enterprises, there has been this workflow, this creation of data. So on the left-hand side of the screen, we have these data sources. So this could be real time, this could be video, this could be all things that are a challenge for any enterprise out there, whether they're small scale or large scale. Typically, they are talking to fast storage. This is where we have, this NVMe, right? NVMe technology being the latest and greatest of the fast storage. Historically, it went to SAS or it went to Fiber Channel, right? But now we have NVMe, which is a big jump there. And then there's always been in the enterprise a backup process. And over the last decade, that backup process really had moved to object. So really the sweet spot here in terms of when you look at this big picture, people who are involved or not involved, they've been pushing their data from the data types and structured data types and unstructured data types has slowly been moving to this object store, which is really that pool that you want to stick your straw in and push up to the flow on the right-hand side of the screen, right? So the AI and analytics. Depending on what you're doing, you have this fast tier that's going to exist. That fast tier has changed because the scale of it, in order to do the training that Steve was talking about, you need a lot of storage, and it needs to be fast storage to really keep those GPUs that you bought fed. And again, from the picture that I like to add, and again, I'm still in process of working on, is sort of the cyclical structure of this, where Steve talked about this checkpointing and other things that you're going to have to go back and reach at a point in time, and that point in time could be on flash, or it could even be in HDD storage. So the cycle is really, you can think of this as a circle, and it's really moving from data scientists, large HPC, national labs, and these projects that are at scales that we don't understand, they're so big, to enterprises that really, in order to stay engaged with their customers, need to deploy this stuff. And that's the exciting part of AI and exciting part of having this portfolio that can be leveraged at any of these tiers. And that's really what we're focusing on is, okay, what is this being used for? Is it an enterprise, more like an enterprise where it's a smaller scale and needs high availability? Or is it something that the scale is really just enormous? And really what I'm chasing is the TCO value of that architecture, because I can't afford that. I can't afford to put flash everywhere. Like I always say, hey, if I could afford to put all this stuff in DDR or some other persistent memory, I would be doing it, but that's not the reality. The reality is we have to think about how much does that data cost, and if there's a way that I can always just keep the fast storage hydrated and then moving from faster to slower, I'm successful. So that's really where OSNexus has all these tools to allow customers to see their data and see where it needs to be, so that they don't overspend on something that might not be moving.
Yeah, I just want to, go ahead.
Go ahead, Steve.
I was going to say, yeah, and the portfolio of systems from Supermicro, from the hybrid, the 4U36 to the high density 90 bays, and now the 32 bay NVMe really gives some really great options for tackling different types of problems. If you need both object and a parallel file system, QuantaStore on the all flash units is a great way to go. And you can start these as small as 4 nodes. We can do 2+2 erasure coding on any of these different combinations to get it down to a small number of nodes that you can then scale.
Steve or Paul, either one of you guys seeing any, or anything, like you're seeing a lot more hybrid, a lot more flash, a lot more, I mean, is there any specific configuration you're seeing a lot of out in the field, or is it sort of a mix of everything?
Well, I think the flash has really taken off because, again, there's really no way to deliver the data to the GPU without using flash. So in terms of growth, the flash portion of it, if you look at analysis too, in terms of where the dollars are going, they're going into flash, and that's the flash to address specifically AI. Without a doubt, that is feeding the HDD. But I think in terms of where people's dollars are going, where their money is being spent, and where they have to really be thoughtful, is that the flash tier is something that they're going to have to think about and be very conscious of in order to use that efficiently.
Yeah, I agree. The vector databases, all the indexing, that stuff is just really ideal to have in that flash tier.
So let me move on to another question, and for Steve and Paul, tell us about how the OSNexus QuantaStore object store and the Supermicro's storage server hardware enable these AI applications.
Yeah, so I can jump on this one. In terms of Supermicro, everybody in the industry understands that we have just the broadest portfolio of hardware. So on the screen right now is just what we call super storage. It's just our purpose-built systems designed for storage. That said, there are many other avenues in terms of building storage. It's one of the use cases we see in terms of migration of data is getting closer to that GPU server. Our GPU servers have options for local storage. So the flexibility of the software platform is really key. And this is one of the things that, talking about software defined, and I've been a champion of software defined for the last decade, really has to do with this flexibility that you can't get from a integrated embedded solution, because that data and that management interface needs to be able to be anywhere you need it, whether that's in a compute or whether that's in a dedicated storage cluster. You need that flexibility in order for the management of the data. So this piece, again, talking about being able to move the data from cost-effective storage to this extremely high-performance storage, whatever the cost. So in this slide, we're talking about enterprise systems that have been very common. They absolutely can be used in AI workloads. Coming back to that flow in terms of what the enterprise has been doing, they've got some of those assets there. And again, transforming those systems to an OSNexus platform is one of the other things that makes it really flexible, because it is software defined.
Yeah, I add to that, these units here are like some of the most popular units used in object storage deployments. I really like especially this 36 bay unit, because it provides 6 NVMe slots, so we can do hybrid units that offload all the metadata in the write log into the NVMe and provide some additional storage for just pure NVMe storage of small objects. But the entire portfolio of storage servers and expansion units from Supermicro are all integrated with QuantaStore. We work tightly with Supermicro in their labs to certify new units before they come to market. So you can get access to our fully integrated solutions the minute they're available through your resellers.
And I think, Steve, you have more material about explaining the different features of QuantaStore.
Yeah, just kind of a quick overview. QuantaStore bare metal installs right onto the Supermicro servers to turn them into storage appliances. So you don't need to have any background knowledge of some of the technologies that we use. We use Linux as the underlying OS, and the QuantaStore platform is managing file systems underneath that include Ceph and ZFS. All of the stuff that we're talking about today around object storage, QuantaStore is doing the management of that object storage using a file system underneath called Ceph, which is an open source platform that's been very popular for over about a decade now. And then QuantaStore, as we were talking about, it fully integrates with the Supermicro hardware and these latest models that are all NVMe and hybrid NVMe, from the 36 bay to the 90 bay and this new 32 bay all flash unit. We do a lot of work around security features so that you can use these in a variety of different environments where maybe you need HIPAA compliance, or you need compliance to other government standards like SB 853 for federal and non-federal, the 171 standard. There's full integration with LDAP and Active Directory. So, you've got all these security features that are needed, and role-based access control, multi-tenancy for the object storage, so you can group the object storage into multiple namespaces for different teams and things like that. And then the grid technology makes it so that you can go and take multiple clusters and manage them as one. But I've got a slide on that. But before that, you were asking earlier, or Jerome, you were mentioning data placement and how important that is. I want to touch on that briefly here. And when you are dealing with large language models or really even backup products, you get this mix of different object sizes. Some data will be really small objects. Some data will be larger objects. Large objects are generally easy to work with, whether it's a high, platter, hard drives or flash. But the small objects, that is a challenge when you're trying to write like a 1 kilobyte or 4 kilobyte object to platter storage. It's super inefficient. It causes all kinds of slowdowns when you're trying to read that data from an erasure-coded stripe of data across hard drives. And so what QuantaStore does is it's got this unique tech in it that will go and take those objects and on the fly route them to the optimal storage classification. So just like Amazon has a standard storage class and a standard IA, you can recreate those storage classes within QuantaStore and then have that data automatically route to the optimal location. And this is all done right through the web UI. You just indicate, like in this case, this would be created with a single rule that says anything that's less than, say, 64 kilobytes, put that into the all flash replica tier rather than the erasure coded hybrid tier. But you can get real specific. You can say, hey, I want objects with this file extension or that match this regular expression to go into the flash tier. So depending on how you're looking to optimize, you can go and get quite fancy with optimizing the storage for AI workloads. And this is the web UI. Everything you can set up and totally configure the clusters, and in fact, multiple clusters across multiple data centers and colos, all through the web UI. So really easy to go set up, and we include all the support at deployment time to go and assist with the deployment and setup. And then our subscriptions cover support for 1, 3, or 5 years on the whole solution. So you've got experts at your fingertips at any time to get assistance with adjusting the configuration or training on the solution. This is just another picture of the grid, just showing how you can deploy across different locations and deploy object storage in some locations, use it for file and object. We also have scale-up configurations that are more compact. They use the dual node units, the scale-up style units that are more for like virtual machines and things like that. And you can throw all of that into a storage grid, manage it all as one. And yeah, one last thing I wanted to touch on here is one of the biggest challenges when building these large object stores is how do I upgrade it? How do I deal with this when the equipment starts getting 4, 5, 6 years old and I need to both expand it and phase out the old storage? And the neat thing here is that you don't have to do any more complex data migrations. You can take the new equipment, so the latest models of Supermicro systems with the largest drives and the latest NVMe, and put that into the cluster and keep expanding, and they can be asymmetrical. So here you can see 90 bay units being added into this cluster with 36 bay units. And as it fills up, you can add more and it will automatically rebalance. And when this initial deployment gets old enough, you can just phase it out. We reweight the storage to a level of 0, which will then move all the data off of those nodes and onto the remaining nodes, and then we can phase out that deployment. And we do all of that with no downtime. And we provide assistance with all these kinds of configuration changes, but these can all be done right through the web UI. You can go in there and select the devices on those nodes, set them to 0, and it will automatically migrate the data off of those legacy nodes so that you can continue to upgrade and phase out old equipment. Oh, I'll pass it back to you, Wendell. You're on mute.
Yeah, that's very impressive, Steve. So you don't have a bad experience and get fired like Jerome's boss, uh, his experience.
Yeah, we
Um,
use double, triple parity, usually triple parity on bigger clusters, and you can even use quadruple parity. It all depends on kind of the scale of a cluster so that you can have those node outages and nobody loses any sleep.
Yeah, no, it's very important for enterprises. And speaking of enterprises, our next topic is really focused on that, and the issues that enterprises should really be considering when they're implementing AI training and inference. So it looks like we have maybe Paul to get
Yeah.
started on this topic.
So yeah, so just as we've been talking about the prep and the pipeline of the data, um, the enterprises are already experienced with many of this stuff, many of these different protocols and the gear. It's really the challenge has been scale and has been kind of having to adopt something that maybe is more familiar to a national lab with an HPC kind of philosophy. So in terms of just being able to buy something off the shelf and plunk it into the setup has been challenging. Medium to larger organizations have already, adopted DevOps procedures, in which case it's less of a challenge because they've been using DevOps. They've been developing their own bits to move data, to organize data. Steve mentioned Spark and Hadoop that are sort of the legacy of this large scale big data challenge. AI basically just gives us an even better window into that big data. And the Supermicro portfolio is really just overlays very well. So in terms of that flow, data ingestion and data preparation, these are things that enterprises have been doing. And, again, with a small modification, can probably just move into this AI and it won't be quite as challenging. So this model training and the inferencing part of it is relatively greenfield. It's been one of the reasons that Supermicro has been able to move quickly and get a big splash in terms of the greenfield deployments that are at this giant scale. That said, it's not because we just started doing stuff 2 years ago. We've had decades of our investment in GPUs, in cooling, in data center technology so that we can fit and help a customer that now has a new problem. They can come to Supermicro and pretty much get the gear they need, again, on the right-hand side of the screen that is probably going to be new to them. And we have lots of case studies and history with, the largest guys doing this. Obviously, enterprises aren't going to build an XAI type of environment, but they will need to shrink that and then use the tools and the data management tools that OSNexus is going to be able to provide them to get that started and cost effectively. So yeah, so Steve had mentioned earlier in terms of the systems that he really likes. So this is that double-sided storage. So it was harder to tell in the previous image, but the double-sided storage is something that we've been shipping for over a decade. It is, and of course, refreshing that motherboard, refreshing the technology that's in it. But it's short depth, standard depth storage system that has drives on both sides. And that has been key, especially worldwide in areas like Asia, where you maybe have power budget limitations and rack depth limitations. So it's been a very popular one there. If you go to the next slide, we have the one that is the big, very popular for cloud scale. So we have customers that are taking these hundreds at a time, if not thousands at a time, to build scale out clusters. And this just essentially is, from the administrator's perspective, is a 2U server. And we're very comfortable with 2U 12 bays. Now we just added a second row right behind the first. 2U24, we call it simply double. So we've simply doubled the capacity. And because the processors have grown their capabilities, this went from a dual processor system, so you'd have 12 drives for each processor, to now the processors have enough cores that you can have 24 drives on a single processor and able to deploy on a very cost-effective processor that can meet that requirement.
Yeah, one thing I wanted to add to this too is this is so nice having the 4 NVMe slots in here. And the latest generation of NVMe is so fast that when we do a write log offload of all 24 drives, we only need a single NVMe pair for that today. It used to be that to kind of optimize the write log offload for Ceph, we needed multiple mirror pairs of SSDs. Now, with the NVMe being so fast and so durable, we can do that with a single pair. And then that leaves 2 additional drives left over that we can use as all-flash OSDs for metadata, small files, all those other things. So this is just a really optimally designed unit.
Yeah, and we see customers even building smaller flash pools using those drives in the back. So basically getting a tiered solution in a scale-out architecture with just buying this system. So this is really popular. Next. And then, of course, for extreme, tens to hundreds of petabytes, we have our 90-bay top loading system. And again, this does have a small pool of NVMe drives in it. What I'm showing here is actually something that is upcoming. So we're actually even moving to a single processor in this architecture because, again, where this gets placed tends to not need the kind of performance, doesn't need to drive the processor as much. We can meet, most of the time, we can meet the core count requirements with that single processor because of these growing core counts from the different CPU vendors.
Yeah, and when we're designing these scale-out clusters, the CPU core count is really important factor in designing a scale-out cluster, especially in our case using Ceph underneath. But throughput is delivered really efficiently without a lot of CPU horsepower. So on these units, especially for like large language models, reading large objects, it's just all throughput focused. So we can build these with like a 64 core processor and have it be a single socket. And as Paul was getting at, it adds a ton of efficiency, a lot of cost savings and power, which is really important these days as well. And I love that it's got the 6 NVMe bays on the back too. Again, just gives you a ton of flexibility to go and use like 4 of these for the metadata offload, write log, and then have some all flash devices for all flash pools in the same cluster. And nowadays with the 30 terabyte and upcoming 60 terabyte NVMe drives, there's just so much choice, so much density that can be added easily.
Next slide. Yeah, and then finally, this is Steve was talking about sort of that more typical enterprise scale up, that especially the enterprise that are adding AI and other things that maybe they aren't ready for a scale out architecture, but still wanted to do something that needs this high performance and needs high availability. This is, the de facto standard in terms of how you'd want to do that in a simple failover cluster model that you can scale up. You could deploy these as 2U systems and multiple 2U systems that have that high availability, or you could add expansion. So we're able to add, you can see there's 4 PCI slots. So we're able to add 2 very fast networking cards and 2 very fast SAS expansion cards in there. So you can really get to a very large scale in that scale up architecture that is cost effective, because as it gets more capacity, you're really not you're able to build that without a huge expense because you're not buying as many processors or other things.
Yeah, this unit's really ideal, like you're saying, as both a hybrid unit, but because you can add up to 4 of those 90-bay JBODs to it. But just by itself, having 24 slots of 30 terabytes, you can get it up to 720 terabytes of raw NVMe in there. which is, fantastic for like vector databases and things like that. And it's all highly available. QuantaStore's HA technology lets you fail over between the nodes and make sure that that vector database is available at all times. And the NVMe, just fantastic for the small block IO type workloads for databases. I think that's our last slide.
Yeah, let me ask Jerome, you covered some of the considerations for enterprises to really think about as they go out and implement object storage for a variety of use cases. And in particular, did you have anything else you want to add about for AI?
No, just that what we're seeing is these are, when you look at object storage, the use case I'm most often seeing for AI right now is for anomaly detection. I would say that's as it relates to the backup use case, where I'm seeing anomaly detection rapidly become almost the de facto standard now. What's really sort of separating enterprise backup products from other ones, so maybe the mid tier and lower down, just because ransomware is getting so sophisticated in that specific use case that we're now seeing strains of ransomware that are targeted at specific organizations. So traditional maybe ransomware detection algorithms do not work because hackers are now designing them for specific enterprises. So they have to actually do their own anomaly detection and look for that. So, and I've had conversations, specifically, with Steve, who's on this call, but with others where they're making significant progress towards integrating and implementing anomaly detection into their systems. So, but then just that as a broader case, when you're looking at using it for data lakes and AI workloads, again, I don't think there should be really any just from a tactical standpoint. Okay, well, will these solutions stand up, or will they meet our performance demands or high availability demands? One thing I become convinced as an analyst is like there really isn't any concerns about that anymore. I mean, what I'm really seeing is like software-defined storage has really matured. I mean, like where if you're thinking about even the context even 5 years ago, that's really the wrong context to think of it as. I mean, they are very really enterprise ready solutions now that organizations can feel very confident about deploying and using to host production workloads.
Yeah, great. I think really that's a great conclusion to a lot of what we've been talking about, Jerome. And as we wrap up this webinar about how object storage can be used in AI applications for the enterprise in particular, and backup, as you also pointed out. If you had anything else to say, and then we'll move it over to Paul and then Steve.
Yeah, I've got nothing else
Or
to add.
did you cover everything? Yeah, that was
I feel good. Yeah, nothing
very
else to add.
good. Okay, thank you.
Yeah. So, again, I think as Jerome was talking about, that software defined is really the way to do things today. The hardware that Supermicro delivers has things like root of trust and other built-in technology that makes sure that from a hardware perspective, there is no backdoor into this gear. So in terms of it being a robust platform to build on that has all of the security that you need, and then to add a secure storage platform like OSNexus delivers, just gives the customers great value and flexibility, so they can build whatever they need to do and manage it under one pane of glass.
Yeah, I'd like to add to that, just like what Jerome and Paul are getting at, is immutability is a really good feature to have turned on when you're building these object stores, especially like areas where you don't expect objects to be deleted or new versions of it created, like changes to a specific object. That's just a checkbox. You turn on immutability, you can set it for a certain amount of time, and then you are rest assured that, in the event of some kind of cyber attack, that data is unmodified.
Great. Thanks, Steve. And so as we conclude this webinar and thank everybody for joining us. And I'll turn it over to Lauren for some final remarks about how OSNexus and Supermicro are working together and how you can get more information. I guess one plug I'll make is that you can certainly go to the Supermicro website. All of the storage products that Paul and Steve talked about are there. You can configure it. The configuration tool that Steve showed and has links to are on the OSNexus website. We also have a OSNexus solution page on our Supermicro website, which has additional information. But I'll turn it over to Lauren to talk and lead us out on where someone who's interested can get more information and even go buy these products.
Thanks, Wendell. Thanks, Steve, Jerome, Paul. That was a great discussion. I think the best place for people to get some more information would just be either osnexus.com or supermicro.com. You can certainly reach out to me after the webinar. I think my email will be on the follow-up email. But you can also go to info@osnexus.com and the Supermicro website for a demo or anything else you'd like to learn, any questions you have. So thanks everyone for joining us today. And yeah, have a great rest of your day. Thanks, guys.
Thanks, Lauren.